Okay, hello everybody. Welcome to the CISC124 weekly meeting. Just a reminder that this lecture is being recorded. There's a question in chat. Hang on. Someone's asking, in the assignment 3 instructions, there's a piece of code to generate the random words. Can we use this, or are we expected to create our own? So anything in the instructions you can use. You don't have to generate your own version if I'm giving you something in the instructions. Okay, someone's unmuted. Do you have a question? Oh wait, we're muted again. Great. All right. The topic of today's meeting is it's an introduction to unit testing. And I don't think this class or students in this class would have seen unit testing with some sort of library before. So what I'm going to show you today is one of the standard Java libraries that are used for what's called unit testing. Let me think if I have any announcements. I think the assignment 2 marks, well, the assignment 2 grading has been done for the most part. They were published today. I noticed some unusual things about the marking, so you should take a look at your assignment 2 feedback and let me or the TAs know if something odd has happened. It looked like there were a few cases where not everything that should have been marked was marked. So take a look at your feedback and let someone know. In the announcements, I guess after this lecture, I will. Oh yeah, Yu-Chen, I'm still working on A1. I'll explain that in a second. So sorry, what was I thinking? Oh right, in the announcements, I will post which TAs should have marked your assignment 2, because I actually do have that information. Assignment 1. So I didn't give assignment 1 to the TAs to mark. I decided to do it myself. But there's 240 of you, and it's taken quite a while to sift through it all. I'm done about somewhere between a third and a half. I forget what letter of the alphabet I've made it to. But I'm working through them as quickly as I can. You should get them back soon. I mean, for the most part, if you completed assignment 1, you're getting something like 30 something, 36, 37, 38, 39 out of 40. Assignment 1 wasn't meant to be very hard, and most people did fine in it. And that reminds me, I should explain what everybody is doing wrong in assignment 1. Almost universally, so that means almost everybody, made a mistake in the average method. So let me just quickly go to Eclipse. Assignment 1. A1. Okay, where is average? Oh yes. Okay, so average. Now you don't. So because most of you took Python as your previous programming course, average is a bit weird in Java and the other C-like languages. So you run into the same issue if you're programming in C and in C++, and there's a language called D, which is a little less common. These all share roots in, they're all derived from C, and that includes Java. So they all have this quirk when you compute things with the primitive types. Mercy, I'll get to your question in a second. So this particular version of average takes in 3 parameters, and their types are all int. Right. So in Python, if you the int type in Python, there's no limit on the size of the int. So you can take any 2 ints and add them together. And as long as the Python interpreter has enough memory, it will happily add them together and give you the correct result. That's not true in Java. So in Java, the int type, it has a fixed range, right? So there's a There's a smallest int that it can represent, and there's a largest int that you can represent. Similarly, in Java, if you take two ints and you do some arithmetic with them, you always get back an int, right? Even if you divide them. And that's not true in Python either, right? So in Python, if you divide two ints, you get back a float. And so Python takes care of the conversion between types for you. And that's because Python is a dynamically typed language. Java is statically typed, which means once you give a type to a value, it always has that type. So if you take two ints and you add them together, you get back an int, right? If you take two ints and divide them, you get back an int. Okay, now putting all that together, to compute the average, I need to add A, B, and C, and then divide by 3. So the most common solution for this particular problem so far is the following. Right, and so that's the way you would write it in Python, and everything would be fine in Python. The problem is if you write this in Java, it doesn't work, right? It doesn't give you back the floating point or the real value of the average, right? So in Java, what happens is when when the Java sees an expression like this, right? Well, that's the whole thing, right? So Java sees something in brackets divided by 3, right? And so parentheses, they have the highest precedence. So Java tries to evaluate what's inside the brackets first, right? So it goes into the brackets and it sees A plus B plus C, right? Now, the addition has the same precedence, right? Because it's addition. So the rule in Java is Java goes left to right, right? So it evaluates A plus B first. To evaluate A plus B, Java says, well, what's the type of A? Well, it's an int. What's the type of B? Well, it's an int. So A plus B will always be an int. And so you end up with an int value for A plus B. And then you get something plus C, right? That's an int. C is an int. So this entire expression inside of the round brackets is also an int. And then finally, Java says, well, I've got an int divided by an int, right? Because 3 on its own is an int. And so Java uses integer division, right? In other words, it truncates the result. So if you have 5 divided by 3, you get 1 point something, and it gets rid of the something. So you get 1, right? So this gives you the wrong value because the returned value is always an int, right? And so some people try to fix the problem by making one of the values double, right? So now you get back a double value. And if you test this function, this method with some inputs for A, B, and C, you'll seem to get the right result, right? So if you feed in 1, 1, and 1, you'll get back 1/3, or 0.333333, which is the expected answer. The problem is this thing on the left-hand side, sorry, right? Everything is evaluated using int arithmetic. So if you take A and B and they're both large, or they're both their magnitude is large. So if they're both positive and large, or if they're both negative and large, when you compute their sum, the sum overflows, right? So if A and B are very large, you end up with a negative value, and now your average is wrong again, right? So you have to make sure that this sum is not evaluated using int arithmetic, right? You have to force it to some other type. So you have to force it to float, or not float. Don't force it to float. You have to force it to double or long. Either one will solve this particular problem, right? And the easiest way to force it into long arithmetic is to make sure the first value is a double, because now Java sees something plus something plus something. Something plus something plus something, right? So it goes left to right and it sees a double plus an int. So it forces this result to be a double, right? And then it sees a double plus an int, and it forces that result to be a double. And then it sees a double plus an int, and it forces that result to be a double, right? The range of double is very large, so you don't have to worry about overflow so much. It will overflow, but not for int values, right? It won't it can overflow. But not for int values, right? It'll overflow for very large double values, but int's not nearly big enough to cause double to overflow. And so this is the correct way, is one of the correct ways to compute the average. Right? Almost everybody either made the mistake of doing everything with int arithmetic, right? Or they evaluated that using int and then did something to force it into a double, right? Like that. So that doesn't work. This doesn't work. Double sum. Return sum divided by 3. That doesn't work, right? This looks like it should work, but that's an int, right? This gets evaluated using int arithmetic. The thing on the left-hand side doesn't matter, right? So that doesn't work. Someone's asking about a cast. So if I cast the entire thing, that doesn't work because this is still done using int arithmetic, right? The cast happens after that's evaluated. So you're casting too late. What does work, surprisingly, is that. That works because, sorry, this works. That works. So if you cast the A to double, then the rest of the expression is evaluated as a double. So that works. That's okay. But the other ones, they don't work. Right. And so that one little function, so far, are the ones I've marked, of the 80 or so that I've marked, there's only been 2 correct answers. So you have to be careful. You have to be a little bit careful when you're dealing with mixed types, right? And all of this is covered in the int notebook and in the arithmetic notebook, right? It explains what's going. If you read those notebooks carefully, everything's explained in those notebooks, right? So even something as simple as computing the average of 3 integer values is difficult. It's not difficult. It's you have to be careful about how you do it. Lucy, can I explain further why that doesn't work? Yeah, I can explain why it doesn't work. So if you write that, right? So when Java sees this expression, that stuff there is in parentheses. So it gets evaluated first, right? The cast happens after that's evaluated, right? Now, A plus B plus C, that's int plus int plus int. So that's all done using int arithmetic, right? And by the time you compute that sum, it may have overflowed, right? So you take the overflowed result and cast it to double, which is the wrong answer. Okay. So that's why that doesn't work. Okay. Yeah, so that's one of the pitfalls moving from Python to Java, right? So Python takes care of the, well, first of all, Python, you can't overflow when you do int arithmetic. So that problem goes away. When you divide when you divide 2 numbers in Python, you get back a float, right? If they're both doubles or if they're both ints, or if they're int and, if they're both float and int, or int and int, or float and float, you always get back a float. And so you don't run into this problem in Python. The price you pay in Python is Python's a lot slower, but that's a separate story. Okay, so now, Mercy, you had a question. A3 is due on Friday. Yes. If you submit on Saturday, it's a 10% deduction and so on. Yes, that's in principle, that's correct. In assignment 1 and 2, I didn't really care if you handed it in late. So I told the TAs not to apply the penalty. And a lot of people asked for extensions anyway for assignments 1 and 2. Assignment 3, you should try to hand it on time. Okay, so let's do the lecture. Are there any other questions about average? Okay. Introduction to testing. Okay, so testing, which you probably have done a little bit in your previous course. So in 121 and 101, you probably did a little bit of testing, but your testing probably amounted to writing a little program and running the program and seeing, and then looking at the output and checking if the output matched what you expected. right? And so that's an important part of the software development process, right? So on any even medium-sized project, there's almost certainly people on the development team whose sole job or whose main responsibility is to perform testing. Right? Now, testing doesn't prove if the code that's written is correct. Right? It can't prove that, and you'll see why shortly. You can't prove with testing code is correct. So instead, what your goal is in testing is you're looking for errors, right? So you're looking for defects in your code. And that's not the same thing as proving that the code is correct. Right? So Edgar Dijkstra, he was a famous computer scientist and mathematician. He has this quote that says, "Program testing can be a very effective way to show the presence of bugs," right? So looking for defects, but it is hopelessly inadequate for showing their absence, right? So testing can't be used, cannot normally be used to prove that code is correct. Okay, that's not. This was adapted from a Java. Oh no, this is Java. Sorry. Okay, I thought this was 121 for a second. Okay, so. If you've been reading the notebooks, and hopefully you've been reading the notebooks, you would have encountered this class called point2, right? And if I had asked you before this lecture to test the point2 class, right, most of you probably would have written a main method. You might have made another class somewhere, or you might have put a main method into the point2 class, and then called a bunch of methods, right? So you would have called, what am I using for examples? Oh, here we go. So here I make 2 points, P and Q, right? Point 2 has the coordinates 1, 1. Point 2 has the coordinates 2, 1, right? And then I compute the distance between those 2 points. So distance 2 is one of the methods inside the point class. And then you're going to look at the distance between the 2 points, right? Hopefully I called it distance 2. Anyway, distance 2 is supposed to compute the distance between P and Q, right? And so you would have printed out, so what's the distance between these 2 points? So it's 1, right? So because the x coordinate differs by 1, right? You probably would have printed something else like this, right? Here's a copy constructor for point 2 for P, right? So I make a copy of point P. So I make a copy of the point 1, 1. I multiply it by 3, right? So that should change the coordinates to 3, 3. So you're probably going to print that out and look at what does it actually print out, right? And so you'd run this program and then you'd look at the results, which is, I mean, fine up to this point, right? There's a problem. Well, there's lots of problems with testing this way, right? So one of the big problems if you test this way is that someone has to sit there and actually read the output, right? So someone's got to sit here and look, okay, so the distance between this is 1. Is that correct? Yes or no? Right? 3 times this point is 3, 3. Is that correct? Yes or no? Right? Point 2 has a lot of methods. So if you were to test every method inside this main method, you'd have a lot of output to look at. Right? If one of your methods fails, so suppose that method fails, right? Suppose you got back like 5 or something like that. You'd have to go in, fix the distance 2 method, run your program again, and then look for the test that previously failed and now see if it passes. Right? Another disadvantage is that all your tests are in one method. So I can't independently run tests, right? So I can't test one method, just one method. I have to run all of them, right? Because they're all my main method. You can sit there and try to comment outlines of code, but that's really awkward too. You could try to write a program that asks the user which method do they want to test. That's awkward too, right? Now the user's got to type stuff in. And there's no easy way to pick which test you want to run. Right? So even if you could run them independently, there's no way to say, look, I want to run this test, and this test, and I want to ignore the other ones. There's no easy way to automate this, right? Because someone has to read the output. And that's really awkward too if you're testing lots of code, right? So you can imagine if you're testing a very large program that has lots of classes and you have tests for every class, right? You want to run all the tests at the end of the day after you've made your changes. Well, there's no easy way to automate this, right? So JUnit is this thing called a unit test framework. It's not the only one, right? It's probably the most common one for Java, but it's not the only one. There's lots of test frameworks. And so this is probably the first time you've seen a framework, right? So a framework is just a bunch of code, right? And it's a bunch of code that forms a semi-complete application, right? So JUnit is a bunch of code that forms a semi-complete application for testing code, right? And so the framework provides you, well, what does it provide you with? Well, basically it provides you with a bunch of classes, and those classes have some methods, right? So it's basically a library of stuff that you can use to build a program, right? JUnit is a library full of stuff that you can easily use to build a testing program, right? You can automate testing, you can select which tests you want to run, and so on and so on and so forth. Right? Okay, so what's a unit test, right? So a unit test, so a unit depends on the problem you're trying to solve, right? So a unit is context dependent. In Java, a unit is usually a single method. So it's either a class or it's a single method, right? It can be a package too, but usually it's a single class or a single method, right? And a unit of work is a task that's not dependent on some other unit, right? So the idea in unit testing is you test units independently of one another. So if you have a class, you want to test the methods independently of other methods in the class. It's not always possible, but that's what you try to do. So you're working on assignment 3 right now, or you finished assignment 3. Hopefully you've started assignment 3, right? If you haven't started assignment 3, you might want to start it soon. So I'm going to use assignment 3 as motivation for writing a JUnit test. Right? So in assignment 3, you've got this problem called dabble, right? So remember, dabble is the word game that you have to try to implement. If I want to write a test for the dabble, I just want to test the constructor for now, right? So the constructor, remember, what does it do? Well, it takes in some words, and then it has to scramble the letters in the words to form the scrambled words, right? So when you make a test in Java, you need a class for the tests to live in, right? And that's just the way Java works, right? All methods live inside classes. So you create a separate class for your tests, right? I need to import the JUnit library, and I'll show you how to do that in a second. And then you write one or more methods that implement the tests that you want to run, right? If you're using Eclipse, and actually if you're using any modern IDE, there will be an automatic way to do all this for you, right? So I'll show you this in a second, right? So we'll come back to this, right? When you write a test, right, you need to decide a bunch of stuff, right? So how am I going to test the constructor, right? Because that's what I want to test in this example. So you have to decide how am I going to call the constructor, right? Or how am I going to call the method if you're testing a method, right? And so what that means is you pick the argument values that you're going to use to call the method or constructor, right? And then you look at what the constructor or the method is supposed to do, right? So in other words, you look at the contract for the method or the constructor, right? If the method returns a value, right, you need to decide, okay, if I call the method with these arguments, right, what should the method return, right? So for example, if I call a square root method with the number 4, I expect to get back the answer 2, right? Sometimes a method doesn't return anything, right? If a method doesn't return anything, then you need to determine what it is the method's doing and how you're going to test what that method is doing. If you're testing a constructor, right, every constructor has a contract that says how it's going to initialize the object, right? So when you test a constructor, you need to determine what is the state of the constructed object, right? And so all of this stuff together forms what's called the test case, right? So we define a test case to be, right, a specific set of arguments to pass to the method or constructor, right? So what are the values that I'm going to call the constructor or method with, right? If the method returns something, what is the expected return value, right? If it does something else, what is the something else that it's supposed to do, right? And if I'm testing a constructor, right, the test case includes the expected state of the constructed object, right? So for the dabble constructor, right, what does the dabble constructor do? Well, you give it 5 words, right? And the constructor has to scramble those words to make the puzzle, right? And so what does the constructor do when it scrambles the words, right? So that what is the expected state of the Dabble object, right? Well, the expected state includes the 5 scrambled words, right? And they need to be words of length 2, 3, 4, 5, and 6, right? So there needs to be these 5 words. They have to be that long, right? What else does the constructor do? Well, it takes in the original words, right, the solution words, and scrambles them together. So every letter in the solutions, right, must also appear in the scrambled words, right? In other words, the constructor should not make up different words, right? It shouldn't make up, it shouldn't use words where the letters in the scrambled words are not in the original solution, right? Now, this is slightly tricky to test because you might have, well, you almost certainly have duplicated letters in the original set of words, right? So somehow you have to deal with all these duplicates, right? And I have to figure out, okay, so are all the letters in the solution words, right? Does each one of them also appear in the scrambled words, right? So let's go ahead and test this constructor. So in Eclipse, I have, let me get rid of that. I've got my solution for Dabble, right? I've hidden the methods, so you can't actually see the solution, right? But I've got the constructors here, right? So there's the constructor that takes in 5 words, right? And there's another constructor here that generates the words from the dictionary, right? I want to write a test for, well, let's say this constructor. And so the way you do that in Eclipse is you need to make a class for your tests, right? So over here in my solution, right, I can just click on the Dabble class. I can right click and say new JUnit test case, right? You can also do it from up here, right? So file, new JUnit test case, right? And you'll get this window that opens up, right? I'm going to use JUnit 4. Jupyter is JUnit 5, which has a lot of nice features. The problem with Jupyter is that it uses a bunch of features that we never look at in CISC124. And so it's hard for 124 students to understand all the features of this framework. So JUnit 4 is a little easier for students in this class to understand. So I'm going to use JUnit 4. I don't need this. That's the name of the test class, right? So it just uses the name of the class and sticks test on the end, right? And you click next, and then it asks you, what do you want to test, right? So you can pick whatever it is you want to test. I want to test this one for now, right? You can add tests later on, it doesn't matter. And you click finish, and then it asks you, do you want to bring in the JUnit 4 libraries, right? And the answer is yes, right? You want to bring in the JUnit 4 libraries, right? So you click OK. And away you go. If you look over here, you'll see JUnit 4 now appears in your project, right? So Eclipse automatically imports the library, and JUnit 4 always comes with the Java version of Eclipse, right? So if you have the Eclipse for Java developers, it automatically comes with JUnit. And you can see that it makes the test class for you, and it even sticks in a empty test method for you. So anything that begins with @test is a method that JUnit thinks is a testing method, right? So JUnit will run this method when you tell it to run the unit tests, right? I'm not going to change the method name. Normally, you would change this because it's this is kind of an awful name for your test method. You would probably call it something else, right? You'd probably call it something like test constructor, right? Oh, sorry, test CTOR, so that's test constructor. There are different conventions for naming tests, not important in this course, right? Whenever you go to work for some company, they'll tell you what their conventions are for writing test names. Here, it doesn't matter, right? And if you save this, you can run it, right? So you just click the run button, and you'll see this over here. So you get the JUnit panel, the JUnit results over here, right? And you can see that it ran one test, right? there were no errors, but there was one failure, right? And it tells you over here that there's this assertion error saying that it's not yet implemented, right? So fail is a JUnit method that causes a test to automatically fail, right? Why does this test fail? Because we haven't implemented the test yet, right? So now we go ahead and implement the test. So I want to test the constructor, which means I have to call the Dabble constructor with some known inputs, right? So I make a Dabble B, and I now need to pass in 5 strings, right? So these are the 5 solution words. So I need a word of length 2, bit. Oops, sorry. I need a word of length 3. I need a word of length 4. 4 words. I need a word of length 5. 5. I don't know. 7. I need a word of length. 6. And these all have to be in the dictionary, so you have to be a little bit careful when you pick these. I guess insert works. That's 6, right? 1, 2, 3. Yep. Right. So I call the constructor with some fixed and known inputs, right? So I know my words are int bit 47 insert, right? Okay, now how do I test this constructor? Well, the constructor is supposed to set the scrambled words, right? So you go back and look at your Dabble class, and hopefully there's a way to get the scrambled words, and there is, right? So I can get the scrambled words because there's a method here. If there isn't a method to get the scrambled words, you're kind of stuck. So if there's no way to get the scrambled words from another class, you can't actually test the thing that you're trying to test. So you have to keep that in mind when you're writing the original class. But I can call this method to get the map of scrambled words. So let's do that. I'm just going to call it got. So there are my scrambled words, right? And now, what do I want to test? Well, I want to test a few things here, right? I want to test, do those scrambled words, are there 5 of them, and are there lengths 2, 3, 4, 5, and 6, right? So let's test how many words there are, right? So int n. How do I get the size of a map? Well, it's just size. So that's how many words are in the map. And I want to check, is that number equal to 5, right? So to write a test that tests if that number is equal to 5, you use the method called assert equals. So assert equals. So that's the method that comes from here, right? So it's one of the JUnit methods that asserts if 2 things are equal. And the 2 things that are equal, sorry, I expect n to be 5. And so when you use assert equals, you always pass in the expected answer, right? So here I expect there to be 5 words in the scrambled words, and that's the actual number, right? So that's the number that I'm getting from the map, right? And so you save that, right? And you run it. And that's great. It passes that test, right? So I know that the constructor has made a map and it's got 5 words in it. Super, right? What else do I need to test? So I'm now going to start numbering my tests. Okay, so that's test 1. Here's test 2, because I can't have them all have the same name, right? Okay. So I know that it has 5 words in it, right? Now I need to check, are the do they have length 2, 3, 4, 5, and 6, right? So that's going to be this test here. So I want to test, does the map, right? Does it have a string of length 2? Does it have a string of length 3? Does it have a string of length 4? And so on and so on and so on, right? And so there's a couple of ways you can do this, right? That map is supposed to be the number of the length of the string, right? And that maps it to the actual string. So I can look at the keys in the map and check if 2, 3, 4, 5, and 6 are there. Or I can look at the strings in the map and check if the length of each string so check if the strings have length 2, 3, 4, 5, and 6. Right. This is a little bit it's a little bit awkward because I don't know what type of map this is. Right. I don't know if this is a sorted map or if it's a hash map. And that affects the order of the keys. Right. So if it's a hash map, the keys could be in any sort of order. Right, so I could have a key length 6, then 3, then 1, then 2, then 4, then 5. Right, so I can fix that. Right, so the way to fix that is to take this map and shove it into another map. But this time I'm going to put it into a tree map. Sorted. Right, so I'm going to take this map. I don't actually know its type, right? But I can use a constructor for tree map and pass it the existing map. Right, now remember tree map, that's a sorted map. So I just have to import this first. Sorry. How come it's not letting me correct? There we go, import. Right, so this sorted will be the elements of this map, except now they'll be sorted with the keys. Right? So in other words, the keys will be 2, 3, 4, 5, and 6 now. And so now I can check 4, 2, right? Expected is going to go up to 6. Sorry, what am I doing here? Sorted. Actually, there's a better way to do this. Do I even have to sort? Oh, now you have to sort. What was I going to? Oh, I know what it was. Sorry, I was going to do it this way. I was thinking I was going to do it as for each integer. Sorted. I know that the keys of sorted should be 2, 3, 4, 5, and 6. So I can use a for each loop. Right, that's the Java version of a for each loop. Right, and so I know that the first time this loop runs, length should be 2, and then it should be 3, then it should be 4, then it should be 5, then it should be 6. So now I can assert that length. Oh, this is awkward. Int expected 2 expected is equal to length. Right, and then each time through the loop, expected needs to go up by 1. Right. There. Okay. I should explain what I just did. Okay, so if you look at this, Eclipse is telling you there's a problem here, right? So if you hover over assert equals, it tells you that assert equals object is ambiguous for type dabble test, right? The problem is that thing there, that's an integer big I, and that thing there is an int, right? Java is trying to use equals. So the way that JUnit works is it's trying to call equals on this thing here, the equals method. It's not using equals. Right? It's trying to use the equals method, and it can't do that with exp because exp is an int. So I have to convert it to an integer, and that problem goes away. Right, and now I can run that test. Well, I can run both, right? And you can see now both tests work, right? So I know that my map here has the values 2, 3, 4, 5, and 6 in it. Sorry, that was a bit more confusing than I planned it on, than I was hoping it would be. What else do I need to test? Okay, so I've got that settled. I've got that settled, right? And now I need to test this, right? Does each letter in the solution appear in the scrambled words, right? And so I need to write another test. So again, call the constructor with some known values, right? And now I need to figure out how to get all of these letters somewhere. Sorry, let me grab the map too. So I'm going to grab the map of words, right? So I need to check, do all of these letters appear in the words that are in this map, right? And that's not right. If you try to think of it, so if you try to think about how to do this, you might think, well, I'm going to loop over this word and I'm going to check, do the scrambled words contain an I, right? Does it contain a T, right? Then you might go to the next word and say, well, does it contain a B? Does it contain an I? Does it contain a T, right? But you have to realize that, you know, if that I is repeated 2-3 times, right? So if you naively check, do the scrambled words contain an I, you might be checking that it contains, you might be looking in the scrambled words and finding the first I every time, right? You're not actually checking, are there 3 I's, right? And so you have to think a little bit about how to test this one. And so one of the ways you could do this is the same way that you implemented the constructor, right? You can grab all of these letters and shove them into a list, right? So I can make a list with I, T, B, I, T, F, O, U, R, 7, and insert, and put them all into one list, right? And then I can do the same thing with the words here, right? And then after I do that, I can compare the 2 lists, right? Once I figure out how to sort the order of the lists, but you can easily sort the lists. So let's try to do it that way, right? So I want to get the characters from each word, and I want to shove them into a list. And I want to do this a bunch of times, right? So if I want to do this a bunch of times, it probably makes sense to insert a method, right? So I'm going to make a little private method here. And call it string to list. So this method is going to take a string s, and it's going to make a list of the characters in the string. Right? Eclipse is complaining that it doesn't know what list is, so make sure you import list. When you import list, it's always Java util, right? It's almost never java.awt. AWT is the GUI, is part of the graphical user interface toolkit. You normally don't want that one. Right? So I need to make the return value for the method. I need a list, so you almost always pick array list. The last thing I'm going to do is return the list. You have to import array list. Right, and so now what do I want to do? Well, I want to loop over the characters of the string, right? So I equals 0, I is less than s.length. Right, I want to get each character from s and put it into the result. So result.add car at I. Right, and so that takes a string s, takes the characters from s and puts it into a list, and then returns the list. Right, so now down here, I can call it for each one of these words, right, and put those into a list. So this character, so these are going to be the solution. Let's call it solution letters. Right. And I need each one of these words. I need to convert those into one of these, into a list, and put it back into solution letters. Right. So solution letters. So list has a method called add all, where you can give it a list, and it will take all of the elements of the list and put it into the other list. right? So I can take all the letters from here and put it into solution letters, right? So how do I get all the letters for it? Well, I call string to list with the string it, right? So that'll take the I and the T, turn it into a list, take the letters in the list, and put it into solution letters, right? And I'm just going to do that for each of the 5 ones. For each of the 5 words. It, 4, 7, insert. Right. So now solution letters contains all the letters of the solution words. You're going to do the same thing for the scrambled words, right? So I'm going to make a list of the scrambled letters, right? And now I want the string of length 2 from scrambled, from got, sorry. And then I want the string of length 3 from got, and then the string of length 4 from got, and so on and so on and so on, right? Alternatively, I can just loop over the strings that are in the map, right? So the way you do that is as follows. So for each string s in got values. So got's a map, right? And a map has a method called values, right? Where values returns the collection of values in the map, right? In other words, it returns a collection of the strings in this particular map, right? Remember, that's the key type, that's the value type, right? The keys are unique, 2, 3, 4, 5, 6, right? The values are the strings that correspond to the key of length 2, the string that corresponds to the key of length 3, the string that corresponds to the key of length 4, and so on and so on and so on. Right? So you write that, and then I can just do scrambled letters. All. String to list. S. String to what's the problem? Did I spell it wrong? String to, oh yeah, I spelled it wrong. There we go. Right. And now I have my 2 lists of letters. Right. So I've got the solution letters, I've got the scrambled letters. I now want to compare if they're equal. Well, not quite, because I don't know what order they're in. Right. So now I want to sort them. So how do you sort a list? There's 2 ways. The easiest, one way is to use collections, the class. The other way is to use the list method sort. Why don't I do that too? So scrambled. So the other way to do it is to use the sort method. Sort needs what's called a comparator. So it needs it needs an object that can compare 2 strings. If you pass in null for the sort method, it'll generate a comparator for you. So it will use compare to in the string class, which will compare the strings for you. So that's those are the 2 different ways that you can sort. And now I can check, are they equal? So it equals the expected, I guess it's solution. And what you actually got are the scrambled letters. Right. So that's one way you could test whether or not the scrambled letters, every word in the solution, every letter in the solution, sorry, also appears in the scrambled letters. Right. And if I run that, hopefully my solution passes, and it does. Right. So that works fine. Right. Now I can go into the constructor and introduce an error. So where's the easiest way to introduce an error? Function shuffle. What is the easiest way to introduce a silly error? I guess the easiest way to do it is to just going to stick an A onto the end of one of these strings. And if I run the test will fail now. So there you go, right there. And when you look at the error message, sorry, here you go. Right. So here, right, it tells you I expected this list with these letters in it. Right. So those are your solution words. But instead, I got the list with all of these letters in it, right? So it's got a bunch of A's in it because I stuck an A onto the end of every word, onto the end of every letter, every word, sorry. Right? And so now it tells you that why this assertion failed. Right? And so now when you find that there's an error in your constructor, you go back and you look at your constructor and you delete the error in this case. Okay. And then you go back and you run the test. Right? And now at this point, you have some confidence, right, that your constructor is working. Right? One of the things you should recognize that when you're writing this test, these two tests up here are not hard to write. Right? Those are pretty easy. Make a dabble, get the map of words, and then check does it have the right number of words. Right? Make a dabble, get the map of words, and then check is there a word of length 2, 3, 4, 5, and 6. Right? This test is quite a bit harder to write. Right? It involves making this little method here that adds the letters of a string to a list. Right? And then it involves iterating over these the list of words here and the map of words here. Right? And then sorting and then checking if they're correct. Right? This test here is probably of comparable difficulty to write as the constructor that you're testing. Right? So in other words, the paradox of testing is that you're writing code to test code. Right? So if you make a mistake here, and it's easy to make a mistake here, right? You're going to have a test that's incorrect. Right? So your test may be giving you incorrect information. Right? And so writing tests is often it's not easy. Right? Sometimes it's easy. These two aren't terribly difficult, right? But this test is quite tricky to write, right? And so you have this issue of writing a test where the test that you're writing is of the same magnitude or sometimes harder than the method or constructor that you're trying to test, right? And that's an example right there. Okay, there's a little bit more time, so I might as well talk quickly about testing one of the methods, right? So this Dabble class also has a method called exchange, where you're supposed to switch two letters in the scrambled words, right? So if you're going to test this thing, right, you want to test if you can successfully exchange letters between two different words, right? So if I want to switch the first letter in the string of length 2 with the third letter in the string of length 4, right, you want to test if you can do that. If you think about it for a little while, though, it's easy to make the mistake where the exchange method doesn't work when you try to switch letters in the same word, right? So that is, there's an obvious answer for exchange that doesn't work. Not obvious, but there's a way to easily make the mistake in exchange where you can't successfully exchange a letter in the same word, right? And then there's there's the case where someone might try to exchange the same letter in the same word, right? And so you need to, and so a careful tester will write at least these 3 test cases, right? And so there'll be a separate test for each of these cases, right? And so the tests for these works the same way, right? You make a method. This time I'm going to test the exchange method, right? To test the method, you need to make an object. So I need to make a Dabble object, right? And then you need to decide which 2 letters are you going to exchange, right? So the exchange happens on the scrambled words. So I need to get the scrambled words, right? And now you need to decide which letters you're going to exchange, right? And so which two you picked, it's up to you, right? So I'm going to pick the first letter in the word of length 2, and I'm going to pick the second letter in the word of length 3, right? So I want to exchange D dot exchange, right? So length 1, that's the length of the first of the word, right? Index 1, that's the index in the first word. Length 2, that's the length of the second word. And index 2, that's the index in the second word. Right, so I want to exchange those. Right? Now, I need to know, right, to test that I've successfully exchanged them, I actually need to know what is the word of length 2, and I need to know what was the word of length 3. So I have to get those. Right? So string s2 equals dot get. Right? Give me the word of length 2, and give me the word of length 3. Right? And then I exchange them. Right? So I exchange the letters in the two words, and then string, I guess after exchange. So T2 and T3. Right? So S2 and S3, those are the strings before I exchange. Right? T2 and T3, those are the strings after I exchange. Right? And what do I want to check? I want to check if, so what do I expect? Okay, so I expect the expected is going to be S3 dot car at 3. Right, so that's the, sorry, car at 1. Right, string 3, car at 1. Right, that should now be sitting at T2, car 0. Right, so in other words, the right, so here, so the second letter in the third string of the original third string should now be sitting at the first letter in the string of length 2. Right, so save that, run that. Hopefully it passes. It does. Right, 4 test run, no failures, no errors. Right. And now, so S2 car at so what am I switching here? Car at 0, right? 2 0 should be the same as T3 1. So those are the two things that have been switched. And again, it passes, right? Let's just make, I'm just going to introduce an error in the test. Right? So if I put in the wrong index here, this test should fail. Hopefully it does, right? And it tells you here, here you get a funny answer, right? Here it's expecting 105, but it got 98, right? You get 105 because a car is an int, right? So you don't actually get the letter that you were expecting, right? Because it prints out the numeric version of the letter. It prints out the numeric value of the car instead of printing out the car itself, right? But that's the correct test, right? Again, that's kind of a tricky test to write, right? Because you have to index into, you have to pick the right index for the right string to make sure to compare the two strings, right? But that's how you would test exchange, right? And of course, you would test the other two cases as well, right? So that's one test for that case. You would try to test this case, and you would try to test this case, right? Now, Notice what you don't try to do, right? Here I picked the string of length 2, and I picked the string of length 3, right? But I could have easily picked different strings, right? So I could have picked the string of length 2 and the string of length 5, or the string of length 3 and the string of length 6, right? Here I chose to swap the first and second letters, right? But I could have chosen to swap other letters instead, right? And so there are lots of different test cases here for this one test, right? Here I'm only picking one specific example, right? So I'm picking one specific instance for this test case. And this is why testing can't prove that something is correct, right? There's lots of different test cases you could use here, and I didn't test every single one of them. So unless I test every single one of them, right, I don't know for sure that this method is correct, right? So if you can enumerate all the test cases, then there's a chance that you can test that this is in fact correct, right? But in many cases, you can't enumerate all the possibilities, right? So for example, if you have a method that takes in 2 doubles, right, there are 2 to the power 64 double values, right? So all the test cases would be 2 to the 64 times 2 to the 64, right, which is 2 to the 128 test cases, which is a gigantic number, right? You can't, if you try to test all of those combinations, you would never get, your computer would sit there for a long, long time just testing all those test cases, right? So one of the reasons that testing can't prove that your something is correct is because you can't actually enumerate all of the test cases. Okay, so that's been an hour. Does anybody have any questions about testing? Testing is something you'll do probably more if you take the software engineering courses. I don't know where else you'll have to do it. The other place you'll do testing is if you end up in a professional environment somewhere, right? So if you end up in a professional job, you'll end up, you'll almost certainly end up doing testing of some kind, right? If you're doing Java, you might use JUnit, right? If you end up in a web developer job, then testing is a bit different because you need a testing framework that can deal with the graphical user interface on most web pages, right? So those end up being JavaScript test frameworks for the most part. All right, any questions? How about, does anyone have any questions about assignment 3? Or any other questions about assignment 3? Does anybody? No, going once, going twice. Okay, that's the end of the. Oh wait, when will the mark for quiz 1? Those went up today. When will they be uploaded? Oh, so I guess did I make a grade book for quiz 1? Yeah, I don't know if I have a grade book. If I have a grade entry for quiz 1. OnQ is a bit funny because unless I make a grade entry, it doesn't. A lot of students don't realize that the thing has actually been marked. Oh, sorry, hang on, I got some music playing. There. Do I have OnQ open? Here, CISC124. When did I publish those? I think those have been published for a while. So, just a second here. Quiz 1 was published a while ago. Where is it here? Yeah, quiz 1 was published on February 18th. So if you go into OnQ and you go to assessments quizzes and click on quiz 1, you should be able to see the feedback and stuff for it there. Yeah, there you go. Click the read feedback under the quiz tab. I will make a, I guess if I make a grade entry for like a grade book entry for it, you'll be able to see that. Yeah, sorry, Adam. It's I haven't made the grade book entries for it yet, which is the problem. I'm having a bit of trouble with the exchange method. Is there a note or anything to help more with string builder? String builder. So in the assignment, I'm just opening up assignment 2. Drag this over here. Okay, wait, this is CISC124, 7.3, right? Where did I tell you? Here we go. Okay, so for assignment 3, string builder. Well, okay, so what's in the assignment should be enough to get you started, right? So you're going to make a string builder object having the characters in string S, right? So that's how you make a string builder object for a string S, right? So you probably want 2 of these, right? 1 for each string. You can use car@ to get the character at index I, right? And you can use set car@ to set the character at index I, right? And so those are the only, so you need the constructor, right? You want to use car@ to get a character. You want to use set car@ to set a character, right? So inside your exchange method, so I'm not going to open up my exchange method because it's got the solution sitting here. So I'm just going to call it exchange 2. Okay, so what do I need to do? I need to get the string of that length, and I need to get the string of that length, right? Alice, right? You understand that, right? So you need to get those from the scrambled map, right? So you're going to go into the map up here, that thing there, and ask for the string of that length, and ask for the string of that length, right? Can I create? Yeah, UChan, you can always you can always add a method to your assignment. It's not a problem, right? You can always add stuff to your class. You can't change anything that I've given you, but you can always add something, right? So I'm going to assume you have the 2 strings, right? So you have S1, string S1, string S2. Right. And get this from Scramble. And ditto here. Right. So there are your 2 scrambled strings, right? I need to get the, right? That's the character in string 1, and that's the character in string 2. Oops, sorry. Right, that's the index of the character in string 2. Right, so car S4. Oh, sorry. String builder. E1 equals new string builder. S1. 2. It's complaining because they're not set yet. Right? If you hover over that, it's going to say it hasn't been initialized, but you're going to do that here, right? So you'll have to fix that, right? So there are my 2 string builders, right? I want to get the character from string 1. I can ask the builder, or you can ask the string, right? D2 at index 2. And now I want to flip them, right? So I want to put C2 into B1, right? So B1 set car@. Okay, so which character do I want to set in, sorry, which index do I want to set in string 1? Well, I want to set length 1, index 1, right? What do I want to set it to? I want to set it to C2. C2 set car@ index 2. C1, right? So that's basically how you do it. You have to be careful about what happens if the string, you have to be careful if it's the same word. I don't remember, you have to be careful if it's the same word. That's basically how you do it. Right, Alice? That's it, right? So it's just using car@ and set car@. Okay, good. Yeah, so yeah, I mean, Java's well, Python's the same thing. Python strings are immutable as well. Java strings are immutable. So doing things like trying to modify existing strings, you have to go to string builder to do it. So string builder is the mutable analog of string. Okay, any other questions? Anybody? All right, we're done for today, and we'll see you next week.